Morning, Lucy. It's already 8:30. Sorry, we went over some homework. You missed it. Now what we're going to do, class, is work a problem. You're free to use a calculator if you wish. Some of you don't like getting out your calculators during class, but I recommend it. And, or maybe you won't need it. I don't know how good you are at doing math in your head. Some of you are pretty good. Here's my practice problem. The ground state, that's n equals 1, for this hypothetical atom is going to be negative 39 electron volts. The n equals 2 then would be 9.8, and the n equals 3 would have energy of negative 4.3, and then the next one, which is n equals 4, is going to have energy of negative 2.5 electron volts. And then there's some more, which we're going to ignore for the moment. What?
What element is this?
I just made it up, so it's not an
You
element.
made it up? Oh my
Yeah.
gosh, are these even numbers that are?
These are hypothetical numbers. You'll get, on your AP exam, you can get things like 10, 5, that, they'll make up stuff too. All right, so here's the problem. Light of wavelength 3.4 times 10 to the negative 8th meters. By the way, how many nanometers would that be?
It would be 34.
34 nanometers, right. So light with that wavelength, a photon of light with that wavelength strikes an electron of this hypothetical atom. You getting this, Jaden? Jaden, are you comfortable? You look like you're kind of twisted there. Maybe a pillow would help. Maybe if you got a blanket instead of having to wrap your arms up in the hoodie. Jaden doesn't know I'm talking to him, does he? He's out. He's out cold. Jaden, Rice. Morning. You need a cup of coffee? You need to work this problem, Jaden. I'm going to give you a grade for it. Okay, so there's the wavelength of the photon of light that strikes an electron, and when it does, the electron absorbs it and moves up to right here. Absorption. Okay. Then the question is, first, draw all of the possible emission transitions. So copy this on your sheet of paper. This is practice because on the AP exam it's a common question where they'll give you a diagram and they'll say draw some transition lines on it. Transition lines are arrows up or down. So if it just uses that term, transition lines, that's arrows. Got to be pointed one direction or the other, but up or down. All right, so here's the absorption transition line. You are to draw all the possible emission transition lines. Try to get all of the possible ones just drawn. All you're doing is drawing arrows. How many are there? I'm not even sure I know how many there are. How many, is anybody finished?
No.
Okay. How many did you draw? Did you finish, Kyle? Oh, there's more than one.
Oh boy, this is burn mine.
Wait, but it fits the energy?
I'm just asking you to draw arrows pointing down.
Okay, wait,
Oh,
The electron absorbed energy and went up to n equals 5.
what
See
is,
that arrow?
what is the thing for n equals 5 though?
It's, oh, we don't know n equals 5, do we? Oh, I think I meant for it to go to n equals 4. Okay. Because that's the last number I actually know. Okay, sorry. It goes up to n equals 4. My fault. Because I don't even have a number for n equals 5. We wouldn't be able to use that. And at that level, it has energy of negative 2.5 electron volts. Okay, so now, I'm sorry, I messed it up. Go back and erase the ones that you drew from n equals 5 because I did the wrong thing. Draw now all the possible emission spectrum, transition lines, as it makes its way back down to ground state. That's what's going to happen. The electron will get back to the ground state, but it has a number of different ways of doing that. You're showing on the diagram what are all the different ways it could do that. How can it get back to the ground state? One is it could do that right there. See what we're doing? It hasn't reached the ground state, but it could go from 4 to 3. That's one possibility. So I'm saying draw all the possibilities. Has anybody got them all drawn? You think you're done?
Just a whip.
How many arrows did you draw, Kyle?
6.
6? Okay. I don't know what it is. It might be 6. Everybody else getting 6 arrows? Sarah did.
Oh, it doesn't have to be like that. Too bad it is.
Draw them
6? Well, I just drew it.
Yeah, but that looks like you're making right triangles or something.
Well, you know what it is. And oh my gosh, 6? What is this? I got energy.
One possibility that it could go to 4 to 3, and if it does, then it could go to 3 to 2. And if it does that, it could go 2 to 1. So there are 3 possible emission transition lines.
Okay, so
It
this
did
is
that to get down. What's another way it could get to n equals 1? It could, starting up here. It could go all the way to there first, and see that's a different photon emitted than these two. Every time you draw a line, it represents one photon that's emitted.
Okay, so this isn't even math based. This is just going, just doing a thing.
You're just drawing transition lines pointing down. If it does that, if it goes from 4 to 2, then again it could go from 2 to 1. We've already got that. So that's a route it could take. Or it could, if it went from 4 to 3, then it could go from 3 all the way down to 1. That's a possibility, right? And then the last possibility is it could go from 4 all the way down to 1 in one jump. Just emit one photon. Now, I think that is 6. 1, 2, 3, 4, 5. That's 6 different emission transition lines. And you might be asked to label them. If you are, you'd write emission next to each one of them. I'm not going to do that, but you can do that. Now, do you understand what we just did? That's a question that says, what are all the possible emission transition lines?
Okay.
There they are.
Okay. So these are just. So what about the math?
Well,
Energy,
that
does it
question
work
didn't
out?
involve any math. That question wanted you to draw transition lines. But then it could go on to say then, it could ask how much energy is in each one. Well, that's easy. You just subtract these. How much energy is in that photon that's emitted? Realize that each one of these down arrows represents a photon that's emitted now. Okay, so energy of that photon, the energy would be the difference in these numbers right here. See? If it asks what's the frequency of that photon, you would go E equals HF, where E is the difference in those numbers again.
But is the wavelength for all of them the same?
No,
So what is that wavelength for?
that's the wavelength of the photon that hit the electron that made it go up.
Okay.
And And you might be wondering, is that correct? You could check that, but we're not going to right now. And let's finish what I was doing. If the arrow is going down, how much energy is that? You subtract. What's the frequency of that photon? Take that energy and divide by h. Make sure you use the electron volt version. These numbers are all electron volts, not joules. And if it asks what's the wavelength of that photon, you can go back to this hc over lambda. hc divided by lambda. Or you could get f and then uc equals lambda f. I mean, there are different ways to do it. All right, so this gives you frequency of the emitted photon. This would give you lambda, wavelength of the emitted photon. Subtracting the numbers gives you energy of the emitted photon. Okay, let's see how much energy, let's see what's the wavelength of this photon right here. See which one I'm pointing to? That, boom, emits a photon. Question is, what's the wavelength of that one photon that's emitted when the electron jumped from the fourth energy level all the way back down to the first energy level? It had to give off a bunch of energy. That's a photon. You would use that equation, wouldn't you? Got your calculators? What's the energy of that photon? You subtract. I don't know what that is. That's something like 36.5, isn't it? All right, so energy is 36.5. HC is 1240 if you want your answer in nanometers. So somebody divide this by that, what do we get? You get 34 nanometers? Were you expecting to get 34 nanometers?
Yeah, that 4 is really pretty.
See this? That's the wavelength of the light that it absorbed down here to make it jump up. So it should make sense if it then drops all the way down in one motion, in one photon emitted, it would be the same. It would. However, that's just one possibility. It could emit a photon here and one here and one here. If the question could say, what are the wavelengths if it emits 3 photons on its way down? Well, there's only one way it could emit 3 photons, and that would be to emit this, one here and one here and one there. Okay, so I'm showing you all a bunch of different possibilities. But all those questions are calculated with these equations here. Frequency, wavelength. Okay. Now, do you feel like you're okay with the energy level diagram questions now? You got the idea in your head. It's going to make sense. Okay. All right. Then, in the time we have left, which is about 19 minutes, I want you to work on focus questions and practice tests, which is due Monday. I'm about to hand you your practice test, so we'll turn this off. I don't think Lucy got a whole lot. Well, maybe she got something from this. Do you think you benefited, Lucy, from us going over this with you? Yeah? Okay.
Oh my gosh, it's on her desk. Is that your view?
Yeah. Where do you think Lucy is right now? Why isn't she here?
She's at a triathlon.
Oh, yeah, she told us that. We know where you are. We're not worried about you. Okay, so I'm going to pause this now in case I want to come back and say anything later. Pause it. How do I pause it? Is it the thing up here?